Hey, this is Brock Lemires. We're continuing our study of embedded systems design. We have switched over to the programming language C in order to program the MSP430. And in this video, we're going to look at bitwise logic operations. Okay, you know by now that we've looked at ports and timers, and you know that all the peripherals that exist on a microcontroller all require a whole lot of setup using their configuration registers. And that's a lot of what you do when you program a microcontroller. It's about setting up these peripherals. And you do it with these bit set and bit clear commands. And so you have to go into the configuration registers, figure out which features you want, how to enable certain things, how to clear certain bits, how to enable interrupts, clear flags, change the source of clocks. It's all done with these bitwise operations. And we are now in C, so we got to figure out how we do those. Well, it turns out that you have these bitwise logic operators that are supported, and C provides all the functionality that we're used to. So it provides a complement, and so using tilde, and what'll happen is that you can complement each bit in the argument. This is the exact same thing as an INV command, so the invert command. It's just going to flip every bit. Okay, if it's a 1, it's a 0. If you're not a 1, you're a 0, right? It also has a logical OR. It has which is the stick or the pipe. It has a logical AND, which is the ampersand, and it has an exclusive OR, logical, and it's a little caret. And the way that these works is just like the operations in assembly. They're bitwise, and what that means is that if you have two arguments, you're gonna OR them together. Each individual bit will be ORed with the same location bit in the other argument. So bit position 1 will be ORed with bit position 1 of the next argument. Same thing with AND, same thing with XOR. Okay, so you can think about it as like totally separate OR gates, AND gates, and exclusive OR gates that are tied into every single bit location. All right, the way that these work, it's pretty simple. So here's the syntax. So we got var gets assigned tilde var, that'll invert all the bits. Then here's an exclusive OR gate, an OR. So var equals var ORed with, and then you give it, in this situation, I'm gonna show you how to do it with masks, because the masks are what we're ultimately gonna do. So it could be another variable, but what I'm gonna do is, this could be an example of an 8-bit OR that has a mask of 0, 0, 0, 0, 0, 1. Now, why do we use an OR gate? Well, remember the logic operations for an OR is anything ORed with a 1 will give a 1. So that's how you set a bit. And luckily, anything ORed with a 0 will remain the same. So this mask, if you recall, all the 0 bits represent bits in var that I'm not going to touch. But the 1, no matter what bit position 0 is in var, it's going to override it. Now, C gives us this interesting shorthand where if you are going to assign to the variable that is the argument, you can actually do this instead. So we say var gets assigned, and then you put the actual operator in front of the equal sign. And what this does is it knows by this shorthand that you are going to apply this operation with this value, in this case a mask, to this variable, and then assign it back to that variable. And this is how we do a lot of the bit configurations, because it's a little bit shorter. You can do it either way. They're exactly the same. It's just a little shorthand for syntax-wise. But what this would do is it would set bit 1 in var. The AND operation, if you look at this, var equals var AND with this mask. Remember, if you AND anything with a 0, it clears it no matter what. If you AND something with a 1, it leaves it alone. And so this is a mask that would clear bit 0 of var. And then the shorthand would be this. So you're going to do, ampersand equals of that. We're going to see some interesting things when we go into assembly, because sometimes what we want to do is we want to clear a bit using an AND operation, but the mask that is provided by the MSP430 header, remember, like if I want bit 1, the mask is going to be this, right? Bit 0. It's going to give me 0, 0, 0, 0, 0, 1. Well, what if I wanted to use bit 1? I mean, I'm talking about the text bit 1, bit1 or bit0 from the header file, and I want to use it to clear a value. Well, notice that it's not the right mask to clear a value using the ampersand. So what you can actually do is you can actually take this bit 0 mask and invert it and then use it with the AND operation. So we'll see that in a second. Exclusive OR gate, just the tilde, or not tilde, caret. Same thing, shorthand right there. Then it actually gives you some shifts, so you can rotate left, rotate right, and the syntax for this is basically you do whatever variable you want, do the rotate operator, and then you tell it how many times you want to rotate it. Okay, so let's go take a look at using this. And I want to use masks because I want to get close to the way we're actually going to do this once we turn on peripherals. So let's fire up a CCS project. Board is plugged in. I'm going to call this C_Bitwise logic. All right, and then I got my main.c down here. Life is good, and we're off. Okay, first and foremost, let us set up a couple variables. Let's go int, and let's call it e, and let's put like a bunch. Let's do it in binary first of all, and let's actually create a 16-bit word. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and then let's do int f, and then let's do this in hex. So 0x 1, 2, 3, 1. So this is a 16-bit word. This is a 16-bit word. We defined them. Life is good. Let's come down here. We'll do a forever loop and get our little curly brackets up and running. And let's just do some operations. Let's invert all the bits in E. Okay, so this was, we don't invert all bits in E. Okay, now let's do this. Okay, so when we've done that, what we did was we changed it to all zeros and then a 1. And now what I want to do is I want to set a bit using an OR operation. So watch this. I can go E gets assigned E bitwise OR with a mask. So bit 7, I mean, think about this. It could be 0B, 1, 2, 3, 4, 5, 6, 7, 8, and then that would work. Okay, that would work. This is bit 0, 1, 2, 3, 4, 5, 6. Oh, it's bit 7. So boom, boom. So bit 7. So that mask would work. But guess what? This MSP430 header file, it has a mask for us defined already called bit 7. And since we include that, we can use the same mask names that we did when we programmed in assembly. And in fact, that's what we're going to do. That's what we're going to do. That's it. This is going to be set bit 7 in E. And now I want to clear a bit. Okay, so I want to clear, let's see, at this moment in time, what did I do? I've converted all this, so now it's 0, 1. It's all zeros and a 1 at this point. And then I set a bit, and let's clear bit position 0. Okay, so I'm going to come in here and I'm going to do E gets, and I'm going to do this operation right here. I'm going to go ampersand, and I want to do bit 0. But remember, bit 0, okay, I want to, at this moment in time, once I'm down here, bit 0 is now a 1. The mask that I want to use to clear it looks like this. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? But that is not the right mask when I do an AND, like I talked about before. So what I really need to do is if I did this, then it would be the right mask because I would flip all the bits and I would have that as a 1. So what I can do is I can do this. I can go tilde bit 0. And what that does is the tilde bit 0 went like this. It took bit 0, the mask, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, no, you get the point. And it changes it into this. Okay? And now that is the proper mask to use with an AND operation in order to clear bit 0. So this is really a big concept because you're going to do this a ton. So whenever you want to clear a bit, you got to have this tilde in here. In fact, this tilde will be one of the most annoying things ever because you'll forget to do it and you'll set up your configuration registers wrong and you won't know what's going on. But clear bit 0 in E, and that's that. Okay, so now let's do that. Let's do those same operations, but let's use the shorthand. So E, and watch what I'm going to do now. I'm going to do this OR operation. Okay, so I'm going to do this OR. Actually, we didn't do our toggle, did we? So let's go E, and let's go caret for exclusive OR gate, and then we'll do, E exclusive OR with bit 4, for example. Okay, so this is going to be toggle bit 4. Now the shorthand. Okay, what if I wanted to set a bit? Okay, so I've flipped all these over to zero, all zeros and ones, and just to make it a little bit easier, why don't we do this? Let's make it like that. And so now you have 4 zeros at the end. I flipped it, and at this point it should be, so that I flipped it all over there. Okay, and then when I did this, it set bit 7. Okay, so I should be now, I should have this. Okay, so that's set bit 7. And then I cleared bit 0. So now what I'm going to have is this. And now let's toggle bit 4. Okay, so now I'm going to have this. So I'm going to toggle bit 4 to that. Okay, so now let's do this. Let's do the shorthand, and let's set bit 6. And I'm going to do the shorthand. I do it just like this. And look at that. Look how easy that is. So at this moment in time, I've got this, and I've got boom, boom. This is you're going to use this a lot, so it's worth taking a second. Let's set bit 6. And so now if I think about what this should look like, I'm going to come in here, and I'm going to set bit 6. So that's my new one. Now let's do a shorthand for the clear. So let's clear bit 1. E, shorthand for bitwise and, but whenever you want to clear it, you have to invert the mask. So when I do that, bit 1, what happens is this. So let's grab our current thing, and this is now going to be clear bit 1, and what is that going to look like? It's going to look like this. It's going to be bit 1, we'll go to that. Okay, and now let's do the shorthand for exclusive OR gate. So it's caret equals. Okay, and now I'm going to do bit 3 this time. So now let's grab this and see what it should look like. So now I'm going to toggle bit 3, and that now is going to be 0, 1, 2, 3. So it'll be this. Okay, nice. And then since we're doing it, let's just do this. Let's take F and let's rotate it. So we'll do rotate 1, I guess. And then let's do it again. Let's go F, rotate it. This time rotate twice, and then let's rotate the other way just to show that we can do it. So F, rotate, rotate 1. Okay. All right, let's see how this works. So I'll fire this buddy up. Error. Okay, so I got a little error in here, so it's saying line 14. Well, yeah, I forgot to put an E there. Could have said something. Okay, so I got that. Okay, so now I'm ready to compile this thing. Remember, though, if we don't turn off optimization, it's going to remove everything, so we won't be able to see any of this cool logic. So let's apply and close that. Let's go ahead and fire this buddy up. So I assemble it. And I'm interested in a couple different things. I'm interested in, number 1, I want to see the variables change, of course. So let's go ahead and I put a breakpoint, and let's step and get these initialized. So there's E, there's F. And so let's put the values in, I want to put the values in binary. So I'm going to change these number format to binary. Okay, so there's our starting point, and just like we expect, okay, so that's exactly what we got. I want to look at the disassembly, and here comes our first instruction. So E equals tilde E. Well, lo and behold, what is it? It's just an inversion. Notice that it put these variables E and F into the stack, which is fine, and it uses offset or indexed offset addressing just like it has in the past. And so that's fine. And so there it is. Now if I do this, it's going to invert all the numbers. Boom! That's exactly what we wanted. Now I want to set bit 7. Well, look at what happens. It is implemented with a bit set and a mask for bit 7, just like we would have done it in assembly. So now watch bit 7 of this change. So I'm going to go boom. Look at it, set it. Now look at this. We are trying to do a bit clear by using ampersand with a mask for bit 0, but the mask was not in the right form. We had to invert it. Well, that compiler recognizes that logic and it says, oh, you're just trying to do a bit clear. So it translates that, or it compiles it into a bit clear with a mask for bit 0, which is 1, and there it is. So now I can clear bit 0. Boom, there it went. And now what I want to do is toggle, and look at this. It's an exclusive OR gate. Boom, it came right in as an exclusive OR gate. Piece of cake. So let's go ahead and run that and toggle bit 4. So we're looking in here, it's going to be this bit right there. So I go boom, boom, it changed. Okay, so now let's go down here, and now we're sitting there going, oh, I'm so cool. I'm going to code with this shorthand because it's more compact. Well, what you're trying to do is set bit 6. And what does that compile into? Well, it turns out it compiles directly into a bit set. It's the exact same instruction opcode as the setup here. It doesn't matter. You can code whatever way you want. It translates into the same exact thing. Okay, same thing right here. Here's a bit clear. Oh, lo and behold, a bit clear. So let's do that one. So I'm going to do boom. I did my set. I do my clear right there. And now I'm going to do an exclusive OR gate, or a toggle right there. I go boom, boom. Now let's look at F. So let's rotate it once. This is going to do a logical or a rotate left. It did it. Now let's go 2 more times. 1, 2. Now that was fascinating. This syntax right here, I'm like, hey, I get to do 2 rotates. You know how it implements that? With 2 rotates. So it takes 2 instructions to do that. Who cares? That's what it is. Now let's rotate it back again. And I went ahead and did it. Okay, that's it. That's awesome. So again, I can't stress enough, you're going to use this like crazy when you program a microcontroller, because it's all about those configuration registers and setting up the peripherals. All right, that's it for this video. Nice work. As always, support my channel by subscribing, and see ya.